Okay, good morning, everybody. This is
Good
your
morning, ma'am.
good morning. This is your lecture 10. We are starting with a new topic today, which is greedy algorithms. You have already done a couple of greedy algorithms in your data structures for graphs. So we'll first start with the basic greedy algorithm, and we'll do it for a knapsack first, and then we'll follow up with a couple other examples, and then towards the end we'll do graph algorithms using greedy method. Okay, so in today's class probably we should be able to cover these two topics: fractional knapsack and activity selection. So what are greedy algorithms? As the name suggests, you are trying, this is again an optimization problem where you'll have to maximize or minimize something. So what you try to do at every step is to take the approach which seems best at that point. So for example, you're stuck in a traffic jam, so you see a lane by lane which is empty, so you think that you it'll take you more time waiting in this jam, so you think that this taking this lane will give you a shortcut or a way out of the traffic jam, and you take that, but you don't know what's going to happen ahead. Maybe the lane is too narrow for two cars to pass and you are stuck there later on. But then at that moment, what you think is best for you, you do that. So it's at the moment decision, and that decision is greedy. So when you play cards, you play the best card you have, thinking that this will help you win. Or when you see stocks, you see which one is going up and you invest in that, and rest you don't know what's going to happen. But at that moment you thought that was the best decision. So you put your investment in a particular company stock. So similarly, you see the ranking of a university, it is, let's say, this year it was in top 10, so you go and take admission, and next year it is not in top 50. So things like that. You do things which seem to be best at the moment, but you don't know what comes after. So when we talk of greedy algorithms, we are hoping that when we make a greedy choice, uh, in each of our steps, or you can put it this way: when you make a locally optimal choice. So if you think this particular, uh, at this stage this is the best choice I have, you hope that in all the steps, you by making a greedy choice in all the steps, or you making a greedy choice locally, you will be able to reach a optimal global solution for yourself. So we put it like this: what we did in dynamic programming, we were trying to find an optimal solution, optimizing something, maximizing something, or minimizing something. Here also, we will find an optimal solution, but it will be an optimal solution. It will not be the optimal solution, in the sense, this will be one of the optimal solutions you can get, but it will not be the. In dynamic programming, you'll always get the best. We'll see that in an example. So like I said, make sequence of choices at every step, or at every point when you have to make a choice. Take the best choice possible. So it will not always produce an optimal solution. Okay, it tries to give you. It's a very basic human approach that every stage you select what seems best to you. So again, there are two things that we have to, when we are using greedy method, there are two things we have to take care. One is a greedy choice property. So how do we make our greedy choice? And if you are making a greedy choice, uh, you have to basically justify that what is it that I'm being greedy in. You'll see in an example just in a while. We have to explain what the greedy point is. Where are we being greedy? How being greedy in this aspect will help us to uh, maximize or minimize our goal. Okay. And then you have to have a substructure. So it's not that you make one choice and that one greedy choice is going to give you a solution. Like I said, you have to have, we are going to do something similar to dynamic programming. But then in dynamic programming, you see, if you remember your mathematical equations for matrix chain multiplication or for your traveling salesman, you always have that intermediate k value for which you select a range of values, and then you select the maximum or the minimum. So here what we do, we make an optimal substructure in such a way that when you make a greedy choice, one of the sub problems is empty. Okay, when we see an example, I'll tell you what we mean by that. Basically, we break down our problem into just just one simpler sub problem. Okay, just a second. So the, what is the greedy choice property? There are two things. We say that a globally optimal solution can be arrived by making a locally optimal choice. So we make the choice, greedy choice, which seems best at the moment, and then solve the sub problem after the choice is made. So the choice made by the greedy algorithm